So here we have a set of past paper multiple choice equilibria questions for AQA A-level chemistry. I'm going to recommend you pause on the question, have a go before you review the solution. With that in mind, here is the first question. So a lot to think about here. We are considering Le Chatelier's principle. We can see from the equation that 2 moles of reactant make 1 mole of product. And if I then consider decreasing the pressure, because I'm going from 200 to 150 kilopascals, actually decreasing the pressure would favour the backward reaction, which leads to an increase in the number of moles. That would give us less RM2. If I consider changing temperature, again, we're dropping that by 100 Kelvin here. Decreasing temperature would favour the exothermic reaction. And the exothermic reaction is the backward reaction. That would give us less RM2. If I then go on to look at D, if I'm changing the volume of the vessel to 2V, doubling the volume is essentially halving the pressure. That's going to have exactly the same impact as A, so we're not going to get that. But if I remove RM2 as it's formed, the system's going to try to add more RM2. Correct answer is C. Next question to try. And we have a lot to think about here. First of all, we're going to look at the fact that we've got 2 moles of reactant make 1 mole of product. We have got further information here. When the pressure increases, the mixture becomes paler in colour. So if we are shifting the equilibrium to the right, which is what would happen if we increase the pressure, because there are less moles, and the mixture is getting paler, that tells us the N2O4 is colourless, which means that the NO2 must be what contributes the brown colour. So we can dismiss C and D. We can then look at the fact that we have got a hot oven and the mixture becomes darker when we heat it. I've also added here now the colours that we've just established. Now from there, if we know that decreasing temperature favours the endothermic reaction, we also know that increasing temperature is making it brown. So that tells us that the NO2 is brown, we already know that. The forward reaction must be exothermic because we've established the backward reaction is endothermic. Correct answer is A. Next question. And this is a fairly standard equilibrium mole calculation. We have got a table that I'm going to recommend you do. Initial moles, equilibrium moles. We've got A, B, C and D, and we have already got the information in the table. We know we started with 10 moles of A, 10 moles of B. We can assume we started with 0 moles of product. We've also been told we ended up with 4 moles of B. Now here we start to use the mole ratios. 1 mole of A reacts with 3 moles of B. We've used 6 moles of B, which means we used 2 moles of A, take away those 2, and we're left with 8. I can now compare A to C, which is a 1-to-1 mole ratio. If I've used 2 moles of A, it means I've made 2 moles of C. And I can use C and D mole ratios to see that if 1 mole of C is made alongside 2 moles of D, then if I make 2 moles of C, I'm going to make 4 moles of D. I can now simply add up the total number of equilibrium moles. 18, correct answer is C. On to the next question. Another Le Chatelier's principle question, really. And what we're seeing here is we've got 2 moles of reactant, 4 moles of product. The forward reaction is endothermic. We know that because delta H is positive. So if I increase pressure, it's going to shift equilibrium to the left, which is going to decrease the yield of H2. If I add a catalyst, there will be no change. A catalyst speeds up the rate at which equilibrium is reached, but it doesn't change the position of equilibrium. If I increase temperature, that will favour the endothermic reaction. And that means that I am going to end up with more H2. And if I look at removing CO as it's formed, if I remove CO, the system's going to try to make it. The equilibrium shifts to the right, so that's going to increase H2 as well. So there are 3 possible answers now. To actually get to the final answer, we need to remember something very important. Kc is temperature dependent only. So changing pressure, removing any of the species will not affect the value of Kc. Only temperature does. That means that we can disregard A and D, and the correct answer is therefore C. Moving on to the next question, we have got here enthalpy of formation for O3. So let's have a look at that. We're going to make, this isn't the enthalpy of formation, by the way, it's twice the enthalpy of formation, because that would be making 1 mole of O3. But we've got a ratio here, 3 moles of O2 make 2 moles of O3. Now we're talking about increasing the amount of O2, i.e. favouring the backward reaction. The backward reaction involves an increase in the number of moles, so it would come from decreasing pressure. So it cannot be A and it cannot be C. Both of those would shift the equilibrium to the right. What I can then do is have a look at temperature. The forward reaction is endothermic. We know that because it's plus 142. We know that decreasing temperature favours the endothermic reaction, so we can disregard B. Correct answer is therefore D. And that takes us to the end of this video. Thank you for listening and goodbye.